line, which is what this table is about, we would need those particular proportions. Just as an aside, it's important in your own mind to differentiate between three things. You have concrete, you have mortar, and you have grout. Now, these are very similar substances, but they're to be used for different purposes. Generally speaking, concrete is used for slabs and so forth, but when you're trying to fill cells of blocks up to keep them together, a normal type of concrete that you would use for a typical slab would not be fluid enough to fit in a small cell. And so you're going to be using another type of material which is very similar but has a different proportioning of water, sand, rock, and cement, and that would be called a grout. Similarly, when you're buttering blocks and putting them together, or bricks, you're going to be concerned with the type of mortar that would be used. And as we said, there is M, O, and S types of mortar. Another exhibit that I want you to take a look at is not part of your materials for the exam, but I think it will help you understand the distinctions between the types of mortar. This is a relationship between the type of mortar and the compressive strength. So over here you have compressive strengths running from 2,000 psi to 6,500. And over here you have the approximate cement content by volume, running by 11% all the way up here to 33%. And here we see plotted the types of mortar. Type O is relatively weak because it has relatively little cement. Type N has more, Type S has more, and Type M has even more. As this relates to our building code, we can look at table 2104.7b, 2104.7b, where we have the different qualities or properties of different types of mortar and the use of such mortar. And this table is pretty self-explanatory and is often asked about on the exam. Returning back to our outline and dealing with masonry, one area that you want to be familiar with is this idea of proportioning, and we can take a look at how many pounds of a particular material are required in a mix, and we could answer a question about such a thing, and that refers us to this table 2104.7. We've discussed the issue of lateral support. We did not yet discuss, but the point here is that there's a minimum thickness of masonry bearing walls. If it has more than one story, it's 8 inches. If it's one story, it's 6 inches. And if the type of construction is rubble stone, it's 16 inches. If we have hollow wall units and they extend not less than 3 inches into backing, the distance between adjacent borders shall not exceed 24 inches, vertically or horizontally. If we're going to bond with wall ties, they must not exceed 36 inches. If we are going to bond with joint reinforcement, HJT, then we're going to need one of these for every 2 2/3 square foot of wall area. And the vertical spacing is not to exceed 16 inches. That is to say, from this point to the height of the wall, we can't go more than 16 inches without some form of vertical reinforcement. Item H here describes roof structures and how they're anchored to masonry. Half-inch bolts, 6 feet on center, embedded at least 15 inches. And then there are prescriptions as to how the various joints of the blocks are supposed to be cut. If we are dealing with bricks, we have to keep in mind that water must be able to get out, and so weep holes are to be present. Another topic of particular note is how we deal with chimneys. The idea is that you want to make sure that wood or any combustible material does not get too close. And you have a variety of rules as to what these minimum spacings are supposed to be. The code will also address wood. Of course, it's going to refer by reference to other sources of information about wood. Notice that there are minimum prescribed quality levels of lumber for particular applications, such as A, minimum lumber grades, or a number 3 grade for roof and ceiling loads only. There are minimum moisture or maximum moisture contents of wood as to what we can use. There are also rules about how close untreated wood can get to the ground. In this case, posts and columns, if they are closer than 8 inches, they have to be pressure treated. In the type of construction that has a raised floor and you have combustible materials such as floor joists out of wood, then these need to clear the earth by at least 6 inches. Some of the other issues that the code will deal about once we get beyond these items that are for framing has to do with site work and demolition. There are some general housekeeping rules that the code will require. And so you might be asked something about roadway, required under a contract, and the issue would relate to the code and not necessarily to the AIA documents or to the or to any particular contract. And also, you should note that there are other technical standards that are incorporated by reference into the code. You're familiar with most of these. All of these types of abbreviations can be found in the first chapter of Walkers for more information. What follows now is a more specific discussion of masonry, particularly with concrete block units. We've talked about solid versus hollow. We've talked about types. You should be aware that both in the building code and also in Walkers, you have certain rules about the amounts of these materials. And so you're going to be called upon to calculate, for example, how many blocks are in a wall. And you'll be given a simple rule of thumb, such as 125 blocks for every 100 square foot of wall. And your task is going to be to find out how many square feet of wall there is and then relate that to that simple ratio of 112.5 blocks for every 100 square foot of area. Continuing on in our outline, we've talked about the distinction between mortar and grout and mortar and concrete, and these can also be found in Walkers on page 4.4. We've talked about wall lateral support, minimum thickness of a wall, horizontal distance between ties, and how the roof is to be anchored down. And we're revisiting some of the other items that we've already talked about, but we're putting them here just so that you can have a better frame of reference for marking your reference books. As far as math calculations are concerned, you're dealing with bulk and unit quantities of how you would deal with conversions of materials, such as converting back and forth to feet and inches, such as converting lineal feet to board feet. You have problems that deal with the placement of brick, how much mortar might be needed, how many bricks might be required, and these all relate to tables. You have perhaps some reading of plans that would be involved here, some reading of tables, and some specialty problems, and some problems relating to things such as stair treads. All of these are covered in the cram workbook, and you're going to have sample questions at the end of this module. Do the questions first, see how you do. If you're puzzled or need additional information, look at the cram book. If that doesn't work, then bring your questions into class. Moving onward in our outline, we revisit the framing issue again, here by organizing the information as far as what's going to be required. Framing is relatively straightforward in the Southern Standard Building Code. What you essentially have to realize is that you have a double top plate, a single bottom plate, you have studs spaced every so often, and you have 3 studs minimum in a corner, 1 stud abutting to concrete, and you have some form of diagonal reinforcement or additional reinforcement for structural walls in a corner. You also have limitations as to what type of studs to use in a given situation. For example, on 2301.5, you have minimum lumber grades for different circumstances. Another issue relating to framing has to do with the fastening schedule for different types of components. Here we have on table 2306.1 the type of nail to be used given a particular application. On section 2308 vertical framing, here's where we have a limitation as to the type of studs that can be used. If we were dealing in 1- and 2-story buildings, we have to have at least 2x4s and so forth. 2308.1.5, here's where double top plates are required. Table 2308.1a, here's the rules about stud spacing, and notice that they differentiate here between a lateral unsupported stud height and a supporting of a roof and a ceiling only. And on section 2308.2.1, here's where we're told that we need 3 studs in each corner. Turning back to our outline, we get to topic number 15. And here we get some rules about roof trusses. Now, I'm going to summarize these items, but really the reference book that is to be used for questions relating to roof trusses is the Handling, Installing, and Bracing Guide, HIB 91. This book is published by the Truss Plate Institute. What it intends to do is to show the proper protocol in handling, installing, and temporarily bracing trusses. Now, it's important to recognize that although it says bracing, it's talking about temporary bracing. The issues here are how do you prevent the trusses from falling down before you've got everything in place. The issue of permanent bracing is a design issue, and that's one area where contractors, owners, and architects often become confused. The truss manufacturer is not going to specify the permanent bracing. The permanent bracing is supposed to be in the design of the building itself. A contractor should not necessarily take it upon themselves to define the permanent bracing in a building. That's a design issue and goes back to the architect and engineer that designed the building. What these rules are about is how, once these trusses are manufactured and shipped to us, how we take them off the truck, how we position them, how we put them in place initially, and then how we temporarily brace them until they're all in place and we can get the sheathing on top of them. The first issue with this book is to recognize the major causes of failure. And if you look at these major causes of failure, you may find that jobs that you've had that have had trouble with something like this, you could probably trace that trouble back to one of these major faults here. The first issue addressed is the shipping of trusses, 3.2.3, which is on page 6 of my edition. And it's saying basically if your banded truss bundles are transported in a horizontal position, they should be stacked on the trailer so as to prevent excessive bending. You're also supposed to stack them so they're easy to remove. That is to say, the smaller trusses go on the top of the pile. These banded trusses are transported, and then they're supposed to be left at the job site, and they're not supposed to be simply dropped on the ground. They're supposed to be maintained in a way that protects them from the earth and from moisture, and so that they will not bend. There are a series of diagrams in this book, such as the one on page 8, and a lot of them repeat themselves. This is a diagram. What's important here is if you'll notice the spreader bar, and you'll notice these are towed in. That is very important. To have them the other way would cause instability. And so one of the things you'll see later is that these are to be towed in. There are also some warnings listed in the book. For example, do not lift the bundles by their strapping. And also do not attach cables or chains to the web members. They show us pretty much what they're talking about here. They show us we're not supposed to do this, and they also show us that we're not supposed to do this. On page 11, if we're going to store these trusses horizontally, they should put it on blocking to prevent excessive lateral bending, and this blocking is supposed to be positioned as indicated on the diagram. This would be incorrect. This would be correct. Another issue that is addressed here on page 15 of the book deals with the maximum allowable deflection. And the idea here is that across 10 feet, the maximum deflection at this point here would be 6 inches maximum. You'd have a 3-inch maximum here, 3-inch maximum here. However, overall, there could be along 20 feet still the 6-inch maximum. So you cannot have more than 6 inches of deflection. In mechanically installing trusses, we want to make sure that we support them at intervals of no greater than 25 feet. Smaller trusses, or trusses that are going to be installed by hand, when they are smaller, could be flipped over from using the peak. However, if we have spans equal to 30 feet or more, they should be supported at quarter points so as not to bend the webbing. On page 17, we have the first of a series of figures that show us how we should be bracing these trusses. You'll notice there are end brace, ground brace strut, temporary support wall, ground brace diagonal. Section 4.3.7 again warns us do not permit lines when we're lifting these items to toe out. It'll cause a buckling. And so what they want us to do looks like this. Another issue has to do with installation tolerances, and here what they're talking about are maximum displacements. And what they are referring to in this table has to do with the diagram below it. If you take the length of the truss and divide it into inches, or convert it into inches, and then divide it by 200, you're going to get an answer in inches. The maximum deflection is that answer, or 2 inches, whichever is less. So the maximum deflection in any case would be 2 inches, but it would be possible if we took the length and converted it to inches, then divided it by 200, that the deflection might be even more restricted. You'll notice also that the maximum end displacement is plus or minus 1/4 of an inch. Of particular concern to the Truss Plate Institute is what happens if someone makes a mistake. And the important thing to realize is that since trusses are engineered products, we simply cannot cut them. In order to modify a truss in any way, we have to have permission of the engineer of record. And only the engineer of record can specify what repairs might be necessary. Now, the components of how we're going to assemble our temporary bracing become important. One of the things that the book points out is that using small pieces of lumber to temporarily brace these trusses is not acceptable. All temporary bracing should be not less than 2x4 grade marked lumber and not shorter than 10 feet long. There are now a series of illustrations in this book that pretty much show what they mean. And here we see top chord lateral bracing as an example. And all of these are provided here as temporary bracing methods until everything is complete. The book also has a series of pull-out pages which snapshot the various issues that we've been describing. For example, on pull-out number D, we see the components they're referring to. We have ground stakes that are backups and regular ground stakes. We have horizontal tie members. We have ground brace laterals, ground brace verticals, ground brace diagonals. We also have designations and tables that tell us what bracing patterns are supposed to look like. For example, if our span is up to 32 inches with a minimum pitch of 4 and 12, then the top chord lateral bracing spacing no more than 8, the diagonal bracing 20 and 15 respectively. Item number F tells us that all connections should be made with a minimum of 2 16D nails and that all lateral braces lack at least 2 trusses. Diagram G tells us that cross bracing repeated at each end of the building and at 20-foot intervals. Appendix D of the book deals with certain types of truss tips, suggestions, and recommendations as how to handle them. And then we have a series of diagrams that again show us what we should be able to do and what we should not, in particular the stacking of the materials, which continues on to the next page. And then in some of the appendices we have different bits of information, and here on page 101 in my book we have a series of labels, and these are supposed to be labels that come with the trusses to help us when we install them. Referring back to our outline, we had taken up roof trusses by looking at the truss book. These are some of the items that are important for you to make sure you've noted. There's also issues relating to manufactured wood products. For example, plywood. This is talked about in walkers, but what you should know about is that when you have exterior 3216, the 3216 means the maximum span for a roof is 32. So the first number is for the roof, and 16 is for the floor. So when plywood is stamped with 2 numbers like this, the first number relates to the maximum spacing for a roof, the second number maximum spacing for flooring. And then we have some specialty issues relating to heavy timber construction, which is found in Principles and Practices. You'll notice on the outline it addresses the kind of math calculations that you'll need to be able to do. You'll need to be able to convert lineal feet to board feet. You'll need to be able to estimate the number of wood studs and also to estimate roofing, and all of these are found in the CRAM book. And once again, you'll be given questions at the end of this module. Take a shot at it. If it seems that you need some refreshing, then go to the CRAM book. The next section of the material deals with gypsum, recommended specifications for gypsum board. This is the application and finishing of gypsum board reference book. Looking at the table of contents, items 2, definitions, items 3, delivery and identification, items 4, general provisions are often asked about. And then you have specific applications such as item 16, exterior applications of gypsum board. This book is going to tell us about boards, is going to tell us about the types of nail requirements, the types of screw requirements, the recommended sequence of installing boards, such as the ceilings first and the walls second. It's also going to talk about the use of green board or water-resistant materials, and then rules about the finishing of the material as well. We should be aware of the fact that gypsum board also has controls as to when it's supposed to be installed. There are temperature ranges between 125 and 52 or 125. We should not install this board if temperatures are too great. When we get to the finishing side of it, that also becomes an issue as to the drying time for the finishing. Under the section dealing with general definitions, we have 2.2.5 nails. They're telling us what the minimum specifications for nails are, and then they refer on 2.2.6.1 of type G screws and type S screws and what their uses should be. There's also the provision right below there for staples and what the requirements for staples are. On the next page, there's a general discussion of corner bead, and these are used to define edges for the material. And you'll notice that these beads have names such as a 38, a U38, and what 38 stands for is 3/8 of an inch. Section 3.3 tells us that gypsum board shall always be stacked flat, never on its edge or end. 4.1.3 tells us where gypsum board is nailed to wood cross-furring on ceilings, those furring members shall be not less than 1.5 inch by 1.5 inch and shall be spaced as specified in table 1, 2, and 3. Where wood furring is used over solid spaces, they shall be not less than 3/4 of an inch by 1.5 inch actual size. If we take a look at one of these tables, this one being table 1, we see what the requirements are for the maximum framing spacing. And you'll notice that there are some notes here that you have to be particularly careful of. On ceilings to receive water-based texture materials, either hand or spray applied gypsum board shall be installed perpendicular to framing. And the board thickness shall be increased from 3/8 of an inch to 1/2 of an inch for 16-inch framing centers, and from 1/2 inch to 5/8 inch for 24-inch centers. Section 4.5.1 tells us that gypsum board shall be cut either by scoring or breaking or by sawing. And 4.6.1 says it should be applied first to ceilings and then to walls. 2 gives us fastener lengths. And there's a diagram opposite that shows us how we would interface wall and ceiling. As we're installing the material, we don't want the nails to actually break through the paper. Figure 5 on page 6 shows us the nailing and the spacings for the nailings. And figure 6 shows us double nailings. Section 5.7 tells us when screws are used that they shall be spaced no more than 12 inches for ceilings and 16 inches for walls. Table 3 deals with multi-layer application without